start. Okay. Should be a pretty easy chapter today. It's just on inequalities, so we're basically going to be solving inequalities. There's not a huge difference between solving an equation and solving an inequality. And then graphing these inequalities is going to be even easier than graphing equations like you've been graphing so far. So let's give you a sense for it first. An inequality is one of these signs: less than or equal to, greater than or equal to. Is everyone already comfortable with what those mean? Yeah. Okay. So let's really quick think about x less than 2. What do I mean by x less than 2? I mean x is a number smaller than 2. What's a number that x could potentially be?
1.
Could be 1. It could be 0. It could be negative 1. Could be 1/2. Could be the square root of 2 over 2. Could be pi fourths. Right? Could be negative 97. So how many numbers could I plug in here to give me an answer? Almost infinite. Almost infinite plus 1. So we get all the way to infinite. Right? Doesn't make a lot of sense what I said, but you guys sure said yes, so we'll go with it. So how do we graph these things? When we graph these things, remember what a graph represents. You're plotting all possible solutions. So there's 0, 1, 2, here's 2. This right here is negative 2, negative 4, etc. So, is the number 2 a solution to this equation?
No.
No, the number 2 doesn't work. What about 1? Does 1 work?
Yes.
So 1 works. 0 works. 1/2 works. If we were to plot a point at every single point that works, we'd end up filling in this whole thing, right? And then we put an open circle there to remind us it doesn't include 2. That's x less than 2, that's graphing it out. Now we also use interval notation to represent this. We say it's all the numbers from negative infinity to 2, not including 2. Those are all the solutions. So here's all the solutions, or represented graphically, here's all the solutions. It's just drawing a picture like that. If this were less than or equal to 2, what are we saying? We're saying that we now allow 2 to be a solution. So the graph is almost identical, we just include this one point, so we do a filled-in circle when we graph it. And up here, we use square brackets when we're representing it with interval notation. All the numbers from negative infinity to 2, including 2. You'll also see graphs the way the author likes to draw it. Rather than using an open circle or a filled-in circle, the author, when he graphs it, so 1, 2, he'll do a square bracket like this, and then he'll color in this side, if it includes it. Or he'll do a round bracket like this, and then color in that side, if he doesn't include it. So I don't care if you use the open bracket, or if you use the point that's not filled in. Those are the same thing. Open bracket, circle without filling it in, or square bracket is the same thing as filling in the circle. Those are both the same. Okay, go sit down. I'll let more know. Okay. So, with the rest of these, it doesn't really change much. So let's really quick look at x greater than or equal to negative 3. If x is greater than or equal to negative 3, what are all the numbers that x can be?
Negative 3 on up.
Negative 3 on up. So we start at negative 3, and we go to all the way up means to infinity. So that's our starting point, that's our ending point if we represent this with interval notation. So is this correct? This is all the numbers greater than negative 3. What's the problem with how I have this written?
There's not a bracket including 3.
There's not a bracket including 3. This should have been a square bracket. We're including negative 3. Right. Wonderful. And then when we went to go graph this thing, in our graph, here's 0, 1, 2, 3, here's negative 3. We would have done the filled in circle and it's all the numbers this way, or we could have done the bracket, all the numbers filled in that way. Either way. Keep practicing. Okay, so that is graphing these inequalities, solving these inequalities. Now you might actually be given it as an equation. So you might be given an equation something like x plus 9 is greater than 17. What on earth do we do with that?
Get your 9 on the other side.
You treat it almost identical to an equation. Subtract 9 from both sides. And what are we left with? We're left with x is greater than 8. If x plus 9 is greater than 17, then x is greater than 8. That's your solution, and then you know how to graph x is greater than 8 now, right?
Yes.
So, you'll either be given some equation that you need to solve, like that, or it will just be given to you. Now, one more gotcha with these things is when we flip the inequality sign. 2 is greater than, you're going to have to wait, 2 is greater than -1, right? That makes sense? Now notice, if I add 1 to each side, does it change anything? 3 is greater than 0. Is that still true?
Yes.
Yes. So adding the same number to both sides does not change your inequality. Let's say instead I would have doubled both sides. So then I multiply both sides by 2, so we get 4 is greater than -2. Is that still true?
Yes.
So multiplying both sides by the same number, the same positive number, also doesn't change the inequality. But now let's multiply both sides by a negative number. What's 2 times -1?
Negative.
What's 2 times -1?
Negative.
-2. What is -1 times -1? What's negative times a negative?
Positive.
So positive 1. Is -2 greater than 1? No. So when you multiply both sides of your equation by a negative number, you need to remember to flip your inequality sign. That's the only gotcha. And there's no difference between using greater than or greater than or equal. Same thing. If you multiply or divide both sides by a negative number, flip the inequality sign. Outside that, you solve it the exact same way you solve an equation. Make sense? Okay, so that's 3.1. 3.2 is just working with 2 inequalities at the same time. So you're going to get 2 inequalities ANDed together, or 2 inequalities ORed together. So one example would be x is greater than -2 and x is less than 9. What are all the numbers greater than -2 and less than 9?
1, 7.
So we got 0 here, 1, here's -2, 1, 2, 3, 4, 5, 6, 7, 8, 9. So all the numbers greater than -2 and less than 9 are all the numbers between -2 and 9. Now, since we use just less than and less than and greater than, then we wouldn't include those points. So if we were to write it in interval notation, it's all numbers from -2 to 9. Those are all the numbers between -2 and 9. Right?
Yes.
Or, if you were to graph it, you do circle, circle, and then fill in everything between. That's an AND. When you're ANDing 2 inequalities together, your graph better be just one line segment. Now we're going to go to OR. You're going to notice that OR splits it into 2 different sets. It's not going to combine it into one set, it's going to split into 2. And you're combining it into 1, or you're splitting it into 2. So let's look at the OR. This time I say x is less than -2, or x is greater than 9. Let's check. Is 11 in this? Is 11 less than -2? No. Is 11 greater than 9?
Yes.
So is it true that 11 is less than -2 or greater than 9?
Yes.
Yes, because it's greater than 9. So it was one or the other. It just needs to satisfy one or the other. So 11 would be in here. So let's think about what these numbers are. These are all the numbers less than -2, so that's negative infinity all the way up to -2, not including -2. Together with, union with, the union symbol's that, union with all the numbers greater than 9. So that's starting at 9 and going off to infinity again. Those are all the numbers that work. Let's draw this out on a graph pictorially. So we got 0 right here, -1, here's -2. 1, 2, 3, 4, 5, 6, 7, 8, 9. So here's 9, here's -2. What are all these numbers? They're all the numbers that are less than -2. So that's starting here and going backwards, all those points. Or greater than 9. So starting at 9, not including it, but going this way. Right? And if I would have said less than -2, but greater than or equal to 9, okay, we just fill in that, or we make this a square bracket. So not much different, right? Now, if you're given 2 equations, you're given something like x plus 9 is greater than, I don't know, 15, and let's see, Make sure I don't do something dumb. And we'll say x minus 2 is less than 21. So you're given 2 at the same time. Here's what we got to solve. Again, you solve each of these just like their equations. Only difference is, if you multiply both numbers by a negative number, flip the inequality. So from x plus 9 is greater than 15, what are we going to do with this?
We're going to
Subtract 9, and we're going to get x is greater than 8. Right? And from this, what are we going to do to both sides of this? Plus 2 to both sides. And so we get x is less than 23. So x is greater than 8 and x is less than 23.
Shouldn't that be 6 and not 8? Yeah.
Yes, it should. Thank you.
I was thinking.
Good thoughts. Point them out. Good. So x is greater than 6 and x is less than 23. So we're adding 2 of them together, which is going to give us one segment, and that's going to be all the numbers from 6 to 23. Right? So adding them together, ORing them together, not much different than what you do up here. It's just you're doing 2 at the same time. Good?
Yeah.
And then lastly, we have doing absolute values with inequalities. So let's think for a second about all the numbers whose absolute value is less than 2. Give me a number whose absolute value is less than 2.
1.
So we have 2 there. Okay, you said 1. 1's absolute value is less than 2. Okay, so that's in here. What else? 0. Negative 1. Should we make it less than or equal so that we can do the 2's? We'll say less than or equal to 2.
So it'd be -2 too.
So we include 2 and negative 2, right? What about 1/2?
Yes.
Yeah, negative 1/2?
Yes.
So all the numbers in between 2 and negative 2, right?
Yes.
Are our solutions. Those are all the numbers whose absolute value is less than or equal to 2. So when you have an absolute value like this, when your absolute value is less than something, your absolute value is always giving you 2 equations in one go. So your absolute value is telling you 2 things. It's telling you that our solutions are greater than or equal to negative 2, and our solutions are less than, are less than or equal to 2. If the absolute value of x is less than or equal to 2, then x must have been greater than or equal to negative 2 and less than or equal to 2. So the absolute value of x has to be less than or equal to the positive version of the right-hand thing and greater than or equal to the negative version of the left-hand thing. In other words, if I want to get rid of this absolute value sign here, what I do is I put another inequality right here and take the negative of that number and put it over here. That's negative 2 less than or equal to x less than or equal to 2. So if I was looking at the absolute value of x plus 1 is less than 7, how would I solve that? To get rid of the inequality in this less than case, I'm going to add another less than over here and put a negative 7 and get rid of my absolute value signs. That's when x plus 1 is between negative 7 and 7. That's when its absolute value is 7. And then you can treat that like 2 separate equations, or one equation all in one go if you want. Subtract 1 from each side, what are we left with? Negative 8 is less than x is less than 6. Right? Or you could have broken this up into 2 equations if you don't like that. You could have broken this up into, okay, I know negative 7 is less than x plus 1, and x plus 1 is less than 7. And you could have solved them both separately. It's going to give you 2 inequalities. You know that this and this are true. And so it's the same thing as dealing with 2 inequalities like up here. So an absolute value is always the same as dealing with 2 inequalities. When the absolute value is less than, so go back to the first one we had. Here we were doing absolute value of x less than or equal to 2. When you have your absolute value is less than or equal to a number, then that's the same as anding 2 inequalities together. On the other hand, when we look at this one, the absolute value of x is greater than 2. This is going to be ORing 2 inequalities together. So let's look at what this one turns into. Think about all the numbers on the real number line whose absolute value is greater than 2. Let's look at what we get.
3 to infinity.
So we have 1, 2, 3, here's 2. 1, 2, 3, here's negative 2. So is the absolute value of 3 greater than 2? What's the absolute value of 3?
3.
Is 3 greater than 2?
Yes.
So 3 works. So we want the point 3. What about 4?
Yes.
5?
Yes.
What about 2.5?
Yes.
What about 2?
No.
No, so not 2, but everything greater than 2. Right? Similarly, going the other way, notice, does negative 3 work? What's the absolute value of negative 3? 3. Is 3 greater than 2?
Yes.
So negative 3 works. Negative 4 works. Negative 5 works. Does negative 2 work? No. So not negative 2, but all the numbers less than negative 2 work. So when I say the absolute value of x is greater than 2, this is encoding ORing together two inequalities. So this one is telling me that x is greater than 2 or x is less than negative 2. Let me rewrite this in the same order that we're thinking here. So when it's like this, we'll just keep the greater than. When the symbol's going this way, then what are we saying? We're saying x is less than 2 and x is greater than negative 2. So rewrite it the exact same way that you have it without the absolute value sign, and then flip your absolute value. If your absolute value was less than a number, you're ANDing. If your absolute value was greater than a number, you're ORing. And that's how you go from absolute value equations to two inequalities. And then we already know how to work with two inequalities. Same thing we did in the previous section. Working with two inequalities is identical to working with one inequality. You just do each one separately. Make sense? All right, so let's do some examples of each of these, and then I think we're good. But yeah, that's all the new material is on. Told you, not bad, right? So plotting x less than 2, we don't need to do that. All right, let's look at this one. Graph the inequality and give the interval notation for y is greater than or equal to negative 1. Oh shoot, now we have a y instead of an x. We're in trouble. Oh, no, we're not. It makes no difference. A variable is a variable. So this is y greater than or equal to negative 1. In interval notation, what is that? That's all the numbers from negative 1 up. Oh, but that's what's greater than or equal. So square bracket here. Right? And then plotting that, what would that look like? Stealing these guys as a graph? We start at negative 1 going up. We'd start right here, so you could do the square bracket here going up. Or you could have done the filled in point there going up. I don't care which of those you like. Okay. So that's the first example. Don't think we need to do much more of those. I think you get the point. So let's do a more interesting example. Okay. This time we're doing an OR inequality. An OR means that we're going to have two separate areas that are a solution. And combines 2 into 1, or keeps them separated into 2. So I have 2x minus 5 is greater than 3, or 4 minus x is greater than or equal to 6. We treat the two as completely separate equations at first. So 2x minus 5 is greater than 3. What am I going to do first?
Gonna get your common multiple.
Going to multiply or add 5 to both sides.
Yeah.
Is that kind of blurry? So 2x minus 5 greater than 3. So rewriting that, let's erase these names. We'll assume you guys got the seating, right? So add 5 to both sides, we get 2x. We're not going to have the minus 5 anymore because we add 5. Is greater than 8. That's our first one. And then we're ORing that with. Here we have 4 minus x is greater than or equal to 6. What am I going to do with this one?
You're gonna minus the 4.
Subtract 4 from both sides. And so I'm left with negative x is greater than or equal to what?
Negative
2, not negative 2. We just subtracted 4 from both sides, right? Okay, now I have negative x is greater than or equal to 2. I don't want negative x, I want positive x.
So you gotta just.
Multiply both sides by a negative 1. So multiply that by negative 1, that by negative 1.
So you get x is negative.
I get x is greater than or equal to negative 2, right?
Yeah.
No! When you multiply by negative, flip the inequality.
Right, yes.
If negative x is greater than 2, then x must be less than or equal to negative 2.
Right.
That's going to be the big gotcha. You're going to accidentally go and do that exact step and forget to flip your inequality. So now we have these two things. 2x is greater than 8. Oh, sorry. Let's work with this one again. So we have or. 2x is greater than 8. What are we going to do?
I'm going to divide 2 for both sides.
Divide 2 from both sides and we get x is greater than 4. Right?
Yes.
And now I plot these things. Let's write in interval notation. X is less than or equal to negative 2. That's all the numbers from negative infinity up to and including negative 2. Union together with all the numbers greater than 4. So that's from 4 off to infinity. There it is in interval notation. And if they wanted a graph of it, what would the graph look like?
You just go from
0, 1, 2, 3, 4, 1, 2.
you go from negative 2 on down. And
Negative 2 on down, including negative 2. And then 4 on up, not including 4. Like that. And it gives us two different sections because we're ORing. Good?
Yeah.
All right. Let's do one that ands two together to make sure we're good there. So this time we're anding these two equations together. So let's start with just this equation and then we'll come back and deal with this equation. So I've got 2x plus 8 is greater than or equal to 5x minus 7. Did I write that right?
Yeah.
Okay, what do we do first?
Get your common multiples on those.
What do you mean common multiples?
I mean, common.
Tell me concretely what to do.
You
Add 7 to both sides.
and minus.
And minus 2 from both.
And minus 2x from both sides.
Yes.
Perfect. Minus 2x and add 7. Wonderful. Over here, what are we left with?
15.
15, and that's greater than or equal to, over here we're left with
3.
3x. Or in other words, now, divide both sides by 3 and we're left with
5 equals.
5 is greater than or equal to x. Perfect. Now, let's deal with this equation and see the information it gives us. So we have 5x minus 3 is greater than 3x plus 1. All right, what do we do first?
Add 3.
Add 3
Subtract 3.
Subtract 3x.
and subtract 3x. Perfect. So when we do that on this side, where are we left with?
2x.
And on this side, where are we left with?
4.
4. So 2x is greater than 4, or in other words,
X is greater than 2.
all right, so we have x is less than or equal to 5, and x is greater than 2. We're anding, so this better leave us with one interval. And if we draw out the interval, 0, 1, 2, 3, 4, 5, 1, 2. Oh, x is greater than 2, so that's starting here, not including this, and we're going this way. I'm not sure how far to go this way yet. Where does my interval end?
5.
It ends at 5. X is less than or equal to 5. So 2, 3, 4, 5, and this is our interval, including this point, not that point. Or written in interval notation, that's all the numbers from 2 to 5, including 5. Right? Okay. So, now let's work on some examples with absolute value sign. We did 2 already like that. Let's try one like this, where our absolute value is greater than a number. When your absolute value is greater than the number, you're going to have 2 intervals. When it's less than the number, you're going to have 1 interval. So this is going to be ORing together 2 inequalities. My 2 inequalities are going to be 4x minus 5 is greater than or equal to 6. And we're ORing this with 4x minus 5 is less than or equal to negative 6. Let's make sure that this makes sense for a second. Let's say that my number x, let's pick a number x that's going to work here really quick. Let's say my number x is 10. What's 4 times 10?
40.
Minus 5.
35.
35. So if this whole thing comes out to 35 and we take its absolute value, ooh, what did I screw up?
Is this negative?
You gotta put it in
6 or 4?
absolute. You don't have your absolute value numbers. Links.
You only did negative.
Oh, this is going to give plugging into here is where it works. So 10 is going to either satisfy this or this. Probably shouldn't have said that, getting confusion. Let's just stick with what we have. So we have some absolute value greater than a number. That's going to split it into two different ones, where it's greater than the positive version of it, or it's less than the negative version of the number. Now we solve both these equations at the same time. So with this equation, what do?
You take, add 5 to both sides?
Add 5 to both sides, so we get 4x is greater than or equal to
11.
11. Now what do?
You're gonna divide by 4.
Divide by 4. So we get x is greater than or equal to 11 fourths. So that's this equation. Now from this equation, what are we going to do?
Gonna add 5 to both sides.
Add 5 to both sides, so we get 4x is less than or equal to negative 1.
Right. Divide both sides by 4.
Divide both sides by 4, and we get x is greater than or equal to negative 1/4. Or sorry, x is less than or equal to negative 1/4. So what are our solutions in interval notations? It's all the numbers less than negative 1/4, including negative 1/4, together with all the numbers starting at 11/4 off to infinity. There's our solutions. Or we could have graphed that out. Find those points on number line, plot the 2 points. So same thing he got. Let's do another one. Solve this. So a little bit more complex here. First thing we're going to do, get the absolute value by itself, everything else on the other side. And then we know how to work with the absolute value. So I have negative 4 minus 3 absolute values of x is less than or equal to negative 16. First thing I'm going to do,
I would combine your like terms, so.
we don't have like terms.
I mean, combine negative 4 and negative 3 together.
You can't. That's a negative 3 times something.
Oh.
You can't just do that.
Times by the absolute value of x, right?
No, we want to get the absolute value of x by itself.
Okay, that's a
Add 4 to both sides. So we're going to add 4 to both sides. Let's start with that, see where that gets us. So we have negative 3 absolute values of x is less than or equal to
Negative 12.
negative 12. Now what am I going to do?
We're gonna divide
Divide
negative
by
3
negative
by
3.
both sides.
Divide both sides by negative 3. When you divide both sides by a negative, what do we do with the inequality sign?
We flip it.
Flip it. So then we get absolute value of x is greater than or equal to negative 12 divided by negative 3 is positive 4. So absolute value of x is greater than or equal to 4. Right? So I need to plot all the points where the absolute value of x is greater than or equal to 4. When does that happen? We have x is greater than, so this is going to be ORing together two inequalities. It's going to be x greater than or equal to 4, or x less than or equal to negative 4. And we're ORing these two together. So this or this. And then what are those? That's all the numbers from, this is everything less than negative 4, so that's negative infinity to negative 4, not including negative 4. Union together with, oh wait, yes, including negative 4. Union together with all the numbers from 4 to infinity. Okay. Or plot it on the graph, you know how to plot on the graph. Mark 4, negative 4, and then all the numbers to the right and left of those. We will. Go sit down. You have to be patient. Let's try one a little bit more complicated. Showtime. Hold on. You have to be patient. Okay. So let's try this one out. Here we have 12 plus 4 times the absolute value of 6x minus 1 is all less than 4. We need to get this thing by itself. That's step 1.
So you gotta do the sign by 4 again.
So minus 12 from both sides. And that's going to give us, we have 4 times the absolute value of 6x minus 1 is less than
8.
minus 8, right? Now we divide both sides by 4, and I'm left with the absolute value of 6x minus 1, that's an absolute value, of 6x minus 1 is less than, we're dividing both sides by 4.
Oh,
So
Negative 2.
negative 2, right? Okay, Now I got my absolute value of x is less than, my absolute value of something is less than -2. What numbers have an absolute value less than a negative number?
All of them past 0, going this way.
When you take the absolute value of a number, can you ever get a negative number? What's the smallest, if I look at absolute value of x, what's the smallest I can possibly get to come out? What if I plug in a half?
So
Is a half smaller than 1? What's the smallest number I can get to come out of here?
Like,
There's a million
oh,
answers.
3, that's a small.
No, 0. There's only one answer. That's the smallest thing.
0.
Can I ever take the absolute value of x and get a negative number? What's the absolute value of -3?
3.
Oh, that didn't work. What's the absolute value of 3?
3.
Still 3. Can I ever get a negative number to come out there? So when is my absolute value of x, when is my absolute value of anything less than -2? It never is. So the solutions are no solutions or empty set, however you write it. So this is one with no solutions. No solutions or an empty set. Okay. So that was a good one to do. Those are good. Okay. So that's it. Unless you think we need to do one more example or you think you got it.
You got it.
Alright. So that's it for this section. That's it for the examples. That's all for lecture today. So now we'll do homework and then you have the rest of class for test.
Are we grading your